What does studying applied physics here at the University of Twente actually entail? To that question, we're going to try to find an answer today. Program Director Cici de Beer tells you about the specializations and courses of this program. At the table, I will talk with 4 different students, Nick, Ali, Nienke and Ramon, about their experiences as a master's student. And we'll also discuss some special perspectives, like when you came from University of Applied Sciences, for instance, or when being an international student, maybe from Egypt. Our chat team is fully at the ready to answer the questions you have, so drop them in there. My name is Lars. I'm glad that you're watching and welcome at the online open day for the Master Applied Physics. Yes, so physics is all about explaining the world around us. Today in the studio we have Cici de Beer, Program Director of Applied Physics, to tell you all about it and also to share some information about the courses and specializations we are offering in this exciting master program. Cici, the floor is yours.
Yes, Lars, thank you very much. And welcome all. Thank you for watching and thank you for your interest in applied physics. Now, I also had to choose a long time ago what I wanted to study. I chose applied physics and I did that for several reasons. So on the one hand, I wanted to understand the world around me. So I wanted to understand how, for example, snowflakes are formed or how blue sky is formed. But also I was very much interested in optical effects. So for example, if you have a light source and you look through it, through a curtain, then you see all those patterns form. Or if you have a small slit between 2 curtains, then also all sorts of optical effects can occur. So I wanted to, I was fascinated by that. But I didn't only want to understand the world around me, I also wanted to do something useful with it. So for example, design advanced sensors for medical applications or design very efficient solar cells. And at applied physics, those things come together. So you combine fundamental physics with bringing it towards applications. Now, in our study applied physics, we have 4 specializations where the scientists work that will be teaching your courses. We have the material science specialization, quantum physics, applied nanophotonics, and physics of fluids. And in the next movie, you will see more about what those specializations entail.
In the specialization Applied Nanophotonics, you will be researching photonics and then the interaction of light with the smallest particles on the nanometer scale.
The physics group studies flows across all scales, really from nanometers to multi-kilometer.
For the quantum specialization track, you will become the quantum specialist in these companies, which means you can learn about quantum field theory, perturbation theory, quantum optics, all the very specialized quantum topics.
Material science is the field where you grow, manipulate, characterize, measure materials, ranging from the quantum domain to the macroscopic domain, to learn from materials, but also to make them useful for society.
Quantum mechanics is booming business right now. It's all over the world. You see more and more companies popping up with quantum. But these businesses, they are growing fast, so we need more people to be educated in quantum. So you first have to do 2 mandatory courses. Everyone needs to do those, so quantum information and advanced quantum mechanics. And apart from that, you can choose to either specialize in quantum optics or you can specialize in quantum electronics. That's what I did during my PhD. For quantum electronics, you can think of topics like superconductivity, topological materials, Majorana fermions. All of these topics are addressed. You can do a more theoretical part within quantum electronics, so the computation, DFT calculations, using artificial intelligence within these calculations of the band structure of the materials. Or you can do a more experimental track and then you actually grow new materials, take a look at the materials, characterize the electronic properties. For quantum optics, there are a bit more mandatory courses. You, of course, have to do fundamentals of photonics. You also have to do the quantum optics and the integrated optics course. And after that, you can choose in which research group you will do your master assignment and where you will do your internship. But everything is focused on quantum optics. If you are interested in quantum mechanics, if you enjoyed these courses during your bachelor and would like to know more about it, would like to work in an upcoming business environment like quantum computing or quantum communication, then yeah, the quantum specialization track of applied physics is the track you should choose.
So light itself, already visible light, has a wavelength of about 500 nanometers. The interaction with particles is on even smaller scale. If you want to manipulate this, you have to have structures that are even smaller than this, so half the wavelength or quarters of the wavelength. And that means that you're looking to create structures and particles that are in the order of a few hundred nanometers. So one application that we're working on at the moment together with the Free University is looking at brain tissue from research into multiple sclerosis. We use a very special microscope, a microscope that can see contrast in particular molecules. So it's a chemically specific microscope which is sensitive to vibrations of molecules. Imagine that if a molecule consists of balls that are connected by springs, then they have a particular frequency at which they resonate. And that resonance you can lock into, and then you can create your contrast based on that, and you can see much more chemical information in the brain. The thing that I find fascinating is the interaction of light and matter. When light falls on something, what happens? Why does it happen? Why do these molecules and atoms get into an excited state? The fact that you can calculate the excited states so precisely. So for hydrogen, I think we're now up to 17 digits on the precision of the transitions. Why is this so precise? Why is it light that governs the structure of space? These are big questions. They don't normally come up too much in the general project. But even in all of these projects, there are interesting questions of what is happening with the light and the material. Why is it responding the way it is responding? Can we use this? Can we then make a little machine, a little thing that actually does something useful by having these elusive photons interact with whatever it is we're trying to measure?
So the group does a very large variety of flows, so really from the nanometer scale to the astrophysical scale, so solar systems, let's say. The nice thing about the group is that we do a combination of theoretical, experimental and numerical research, and these are generally also in close collaboration. So on the one hand, I perform most of the experiments with many of my colleagues, of course, but there's also a whole part of the group that does really numerical work on the computer. And then we often have the nice thing that we can then compare one-to-one really the experiments with computational models. And also sometimes we even are lucky that we can also do the theory, and then we can have let's say the trifecta. We can really do the three together and prove it from three different ways. And
so what kind of assignments should I think of?
Yeah, so that's really a large variety. So we've had people working on freezing. So how does freezing work on a small scale? We've looked people at wind farms, at droplet impacts, on printing, on biomedical flows, hardcore turbulence, turbulence with bubbles, particles or heat. It can be microfluidic scale, so really smaller than a millimeter, let's say, with particles inside or bubbles inside. It can really be a large variety. But to help the students, we have a page on our website with a whole list of possible topics to get a flavor of what we do. So I think a good example is, for example, in printing. In a normal inkjet printer, you have a little nozzle that creates the inkjet, right? This ink comes out and then deposits on the paper and evaporates, for example. So there's a whole complex process. So for example, this ejection mechanism we do in the lab. So we have nozzles from collaborators like Canon. We look at this ejection of these liquids, and these liquids are of course ink, so they have special properties that make it difficult. But then we can also use the properties of these fluids in computational models and compare them really one-to-one and explore things that are experimentally very hard, like measuring the flow inside a drop, which would be experimentally nearly impossible, but computationally very attractive to measure them.
As a student in the material track, you learn how you can manipulate materials, how you can characterize materials, but the most important thing you learn is what are the physics inside the material and what determines which physics I have. So for instance, it is determined by the structure of the material, the thermal properties of the material, and also, for instance, how a material behaves if I illuminate it with light. If I shine light on a material, why is it, for instance, conducting better? Or why would it change its shape? These are the kind of questions that you're trying to answer in the material track. If you make a material very small, although it is the same material as the bulk material, it behaves very different. So it means that confinement has a huge influence on how a material behaves. But you also learn on how can I measure these changes and how can I work with small signals? Because you can imagine that if you work with small materials, you also have small signals. A lot of things what we do is actually on a very small scale. So you need all kinds of special setups to actually investigate what you're doing. Because I can tell you that it is growing in a different structure, and then you say, oh, I believe you because you tell it's so nice, but you actually want to have evidence that this is happening. Yeah, so the machines that we use, it's a plethora of setups. So we use scanning probe microscopies, which means that we have small probes actually investigating the surface. So you have to think about scanning tunneling microscopy, of atomic force microscopy. But we also use a lot of X-ray diffraction, because with X-ray diffraction you can actually get out the crystal structure of the material. The thing that makes material science so exciting is that you work on the edge of what people know. So what we're doing actually is we're designing materials which are till this time not known, and to see if it exhibits very new physics. And the moment you see that materials behave differently than you expect, that gives you a really eureka feeling.
Welcome back. If this has caught your attention, then studying applied physics might be something for you. Now you might wonder, what is this program all about? So we have a 2-year master program, each 60 ECs, and in the first year you will mainly follow courses. Now those courses will be general physics courses, but also specialization courses, depending on the specialization that you choose. And there are electives, and some of them are really free electives, where you can choose anything you like. Now the general physics courses are composed of a fundamental physics course, that is quantum mechanics. We have a mathematics course, mathematical and numerical physics. Then you learn some true engineering at heat and mass transfer, and you're going to work with very small signals, because that is something that you will also do during many of the master projects. And then since we're an international master, we also have ethical and cultural awareness. Now in the specialization courses, depends on what specialization you choose, how this is set up. So for example, for physics of fluids, there's the compulsory course Advanced Fluid Mechanics and Experimental Techniques in Physics of Fluids. But the other 10 in EC you can fill up with courses from an entire list. So you're free to choose which one of those you take. For the other specializations, it's set up slightly differently, but all more or less in the same structure. So in material science, you can do nanophysics or maybe theoretical solid-state physics. If you go to the specialization quantum physics, you'll get courses like advanced quantum mechanics, but also quantum information. For the applied nanophotonics specialization, you will have courses like light and matter or advanced photonics. Many different courses you can choose from. If you want to know all the details, it's best to check the website because there all the courses that you can take are enlisted. Now in the second year, it's slightly set up differently. So in the second year, there's an internship and there's a master project. So for the internship, you can either go to one of the companies here in the surroundings, like Demcon or another company, but you can also go to another country, or maybe you go to a research institute or another university, and then bring all your knowledge into practice. And this will happen specifically, especially also at your master project, because there for 40 ECs, you will work really with a professor on your own assignment, tackling a real research question in those specializations that we just saw. Now there's also the option to choose a multidisciplinary specialization. So for example, you can choose the material science and engineering specialization, and then you'll get courses combined from applied physics, chemical science and engineering, and mechanical engineering. And then there's also a true engineering component in the material science. Or you can choose, for example, the fluid mechanics multidisciplinary specialization. And then you will not only have the fundamental physics courses, but also learn how to work in a wind tunnel, for example. Now, if you're interested in those specializations, it's best to contact us. Then we will bring you in touch with the right people. Now, there's also the option to do a double master. We actually have a lot of those. Then you will take a bit longer, but then you'll have 2 diplomas. And you can combine applied physics with nanotechnology, chemical science and engineering, biomedical engineering, applied mathematics, and something that's actually quite popular, also the lerarenopleiding. So then you will learn how to become a teacher in a secondary school. Now, something that I'm also particularly proud of and happy about is the very nice atmosphere that we have here in the program. So teaching is always done together with the students, and there's also a very nice study association, Arago, and they organize a lot of nice events. We even have a special master committee that organize all sorts of events, especially for master students. So yeah, very nice. Now, if you want more information or also for support during your program, during your study, you can always contact our study advisors. And in fact, even one of them is now in the chat, so you can already ask all the questions that you like. Yes, so then the next step might be just hearing really from some students what it's all about to study here applied physics. So let's go back to Lars.
Yes, back to me indeed. Thank you, Cici, for your presentation. So to taste a bit more about that atmosphere, I have Nienke and Ramon at the table, and they're going to share a bit about their experience as a master student in applied physics. Nienke and Ramon, welcome to the studio.
Yeah, hi.
How are you doing?
Yeah, fine. Yeah, fine.
Okay. So you both did your bachelor's here in applied physics as well. So why applied physics? Nienke?
I really liked applied physics because I wanted to know how the world works. And I like the aspect that what you see in real life, you can explain with the physics behind it, so with the formulas and the things that you know what you see. You can explain it to other people that just see it, but you actually know what's happening, and that I really like.
Yeah, Ramon, I see you nodding.
Yeah, I completely agree. And maybe a tad something extra, you also know how to manipulate things to get to new physics or new technologies. That's at the end of the master's, but you know that's the goal in the bachelor and the master combination here.
Okay, cool. And well, we're here in the bachelor at University of Twente, still here at University of Twente. So why the University of Twente?
Why Twente? Yeah, because all of the teachers know you personally. And next to that, the education, like Cici already said, the education is being done together with students. So people who I started to study with, or were only 2 years older, well, 2 years is not that much when you're starting a bachelor, but they are PhD students and they're correcting my homework. One of my best friends corrects my homework.
Okay.
And he's not gonna let me off easy. He's mainly disappointed if I'm not doing very well. But it means that everyone here wants everybody to do good, to do it well and get nice grades and understand everything. So it's more working together and cooperation here than being a student of some grand institute where you need to follow the rules.
Okay. And Nienke, anything to add to that? Maybe also the location?
Yeah,
at campus?
I come from the neighborhood of Amsterdam, so it's very busy and a lot of buildings. And I like in Twente that it's very green. The campus is a lot of parks, trees. It's all located around in close to each other, so you don't have to cycle like 10 minutes from one building to the other, but you can just walk mostly.
Okay, nice.
So that I like very much about here.
Okay, about your specializations. Nienke, you're doing physics of fluids, correct?
That's right.
And Ramon does quantum optics.
Yes.
So can you both shortly tell why you prefer that specialization?
I really like fluids. I'm a sailor myself, so it's kind of in my lane. But I really like that you can, as I said before, you can see what's happening. So when I turn on the tap, You see a cylinder that goes down, and when I close it, the cylinder forms drops. But how it forms drops, that's all physics, and you can all explain it using formulas and theories. And I really like that I all now know how that happens and why that happens. And it's just something that you see in your daily life, which I really enjoy.
Okay. And if we look at an average week in a Master Applied Physics, how does it look like? In the books or in the lab?
I think it's a little bit of everything.
Yeah, combination. Depends on which module and which courses you're following at that moment. But in general, last module, well, we did some courses together. So
Okay.
last module, it was mainly assignments, and assignments already counted towards your end grade, your final grade, and then with an exam, you can get a little bit below the normal minimum, you know. So, and the exam is mostly on the level of the homework assignments, or actually mainly below that even.
Okay.
And so that the exam is only to check if you really understand it. And in the homework assignments, they can be really tough. But that's also nice. I mean, it's just puzzling.
And lectures? Also still have lectures?
Yeah, of course. So
Okay.
the stuff you need for the assignments will be taught in the lecture.
Okay, cool.
But working them out, of course, takes way more than someone says, well, you go from here to here. Yeah, that's takes a little bit of more work than just hearing about it.
Okay, and it's applied physics, so you do also some practical courses, I hope, still in the master?
Mm-hmm. Small signals and detection, like Sissy already said, is a course. And I believe every specialization also have their own...
Yeah. For example, did experimental techniques in physics of fluids. So there I learned how to measure actually the fluid and what kind of techniques there are. So that was really experimental, and we finished it off with like a big experiment. So that was really nice, not only theory, but also something in the lab.
All right, clear. Well, and after the courses you do an internship, and after the internship a master thesis, like Sissy already mentioned. Mm-hmm. But of course there's also a future perspective. And I was wondering, Ramon, do you already have an image of what you would like to do after you finish your master program?
Yeah, I'm also doing the double masters of education. So nice. My ideal view of what I want to do is a little bit of research and a little bit of teaching, and the combination would be best. So a PhD could be a possibility,
yes.
But also 3 days at a research and development department at some company, and 2 days a week being in front of a class at high school. So something like that.
Yeah. Okay. Oh, that's actually quite clear already. Cool. Well, I didn't ask that question for nothing, because Sissy, you have a presentation for us prepared about future perspectives after your master. So I would like to give the word back to you now.
Thank you, Lars. Yes. So after finishing the master, our students have many options. For example, Sophie, she became a data scientist after studying applied physics. René became the CTO of Lyonics after applied physics. And Diederik became a science journalist. Also, if you look at the companies where our students end up, it's really broad. They can go to ASML, to Canon, but also, for example, the Rabobank. Now, about half of our students continue with a PhD. So they will get a doctor's degree. And they will either do that by continuing here at the University of Twente or go to another university and get a PhD degree there. The other half of our students work for a company. And when they work for a company, so then they typically stay in the Netherlands or they can go abroad. Now you might wonder, am I admissible for the master? If you have an academic bachelor degree in physics or in applied physics, you're directly admissible. But if you come from a Dutch University of Applied Sciences, after taking a pre-master program of around 30 ECs, you're also admissible to the program. And you're actually going to hear more about that in the discussion with other students later. If you come from another academic bachelor, for example, AT or electrical engineering, then you can be admitted here, but then there are additional requirements. And then it's best to contact one of our study advisors. They will know exactly which courses you have to take. For international students, they're of course also very much welcome. Those people have to take an English language test, and there are also some minimum requirements for their CGPA. More information on that can be found on the website. Now, let's go back to Lars and see about all those special conditions.
Yes, special conditions indeed. So, admission-wise, there can be some side cases. For example, when you come from the University of Applied Sciences, HBO in Dutch. Nick has done this before. He came to do his Master Applied Physics here. And he enjoyed it so much that afterwards he even decided to do a PhD. Ali is an international student from Egypt. And both of them are here in the studio right now at the table. Ali and Nick, welcome.
Hi, thank you.
So, Ali, I would like to start with you. You've been here in the Netherlands for a bit longer already because you did your bachelor's in electrical engineering.
Yes. Correct.
So, why did you decide to come to the Netherlands?
Well, really, it's a great country. I mean, there's not that much, not to like except the weather, but everything else I find, it's great. I mean, the people are very welcoming. The universities are great. There's a very high level of research and a large variety of topics that you can go into. So I think it's a great environment to be in.
And just the Netherlands in general, what do you like about it?
The whole country. Well, I mean,
maybe cultural-wise?
Well, as I said, everyone is very friendly. So you can always go up to anyone, ask them anything. People are always willing to help you out. So you don't really feel that you're alone necessarily.
Okay, and in comparison to Egypt, where you're from originally, do you notice differences, big differences, or?
Not that much. I mean, things are a bit more structured. I'd say back home things can tend to be a bit more chaotic, not necessarily in a bad way, but I think here things are a little bit more ordered, but then also if you're in an environment where you're having fun, it can also get quite chaotic. So then it's just a balance, yeah.
Okay, no, that sounds good. So as I mentioned, you started out with electrical engineering, a nice study as well, and then you decided to switch to applied physics. Why?
Yeah, so part of the reason is in my bachelor in electrical engineering, I discovered a few modules in that I don't really enjoy making circuits, which can be a problem if you're an electrical engineer.
I can imagine.
And I also generally tend to really gravitate towards the theory aspects of it, but I still want to have some applied elements there. So that's why I think applied physics is a great fit for that, and it's a great balance in that sense.
Yeah, clear story. Nick, you've walked quite a different path.
Yeah, certainly.
You originally did Bachelor of Physics, Applied Physics at the Hague University of Applied Sciences in Delft, not The Hague. So can you maybe name the key differences between a University of Applied Sciences, so that was the HBO in Dutch, and a university?
So I think the most important part is where do you want to go more fundamental than what you're used to. At the University of Applied Sciences, you specifically learn how to use machines, how to develop different things more company-wise instead of doing research. If you fundamentally want to know what's going on, then sometimes going towards the university makes a lot of sense, and that was, with me, especially the case.
Okay, and now you're here at the University of Twente as well. So why did you decide to do your master's specifically here?
Because it's such a small and very open community. You can see it on the back actually right now.
Yes.
There are different pictures of me during my studies, and there are different pictures of what I was like back then at the University of Applied Sciences, and I never expected to find such an open community here as well. And as soon as I sensed that during my open days in 2019, I figured I wanted to go here and try the masters, see what happens. And now I'm doing a PhD, and I decided to stay for 4 more years.
Yeah, that's quite a dedication then.
Yes.
Yes. Okay. Yeah, but indeed, in the pictures we can really see it's the group, right? The bonding, the vibe. It's nice. Okay. Ali, you actually just started out, so you finished your master, but you just started with your master applied physics. How do you like it so far?
Yeah, I think it's quite nice. I actually just got some of my first grades today.
Okay.
And they were better than I expected, so that was a pleasant surprise.
Did you pass?
Yes, I did.
Congrats.
Thank you. But yeah, I find the courses very interesting. Because there's such a large variety in the courses, you really get to choose things that you want to do. So there's not really any courses that I'm following that I don't feel very interested in. And it's a great environment also because
yeah, everyone is friendly, so you can really study with other people. I've just joined the study association as well. So yeah, it's
Argo, right?
Yeah, Argo,
Yeah,
yes.
yeah.
And so it's great that you really get to experience it with other students.
Cool. And did you join an activity already from Argo?
Activities, I can't think off the top of my head, but I did join a committee.
Okay, which one?
It's called Matunda, and they're responsible for buying fruits for the applied physics students.
Okay,
And
good cause.
sometimes baking cakes and pies and giving them to everyone.
Okay.
So it's quite fun.
Okay, thank you very much. We're now moving on to some questions from the chat. And for that, we're going to do a quick switch. So see you back in a bit. Yes, that was quick. Yeah, so we switched Ali for Nienke and Cici, our program director. So we're going to look at some questions from the chat. They should pop up on the screen any minute now. Yes, there we go. Okay, we have a question specifically for Nick. So Nick, why did you stay to do a PhD? Can you maybe tell a bit about the PhD perspective?
Oh, to be honest, I never expected to stay for PhD. This university is all about entrepreneurialism and just preparing you for the broad work field. And then you're starting to do your master assignment, and you learn what's so fundamentally interesting and how you fit into the research perspective. So that really, at some point during my master's assignment, so the final part of my master's, I started to learn about research, and I thought it might be interesting. So why, the PhD perspective, I'm still very much in the student perspective. So I join I'm still in different committees, for example at Argo, I'm still partaking in most of their activities. I still wear my University of Twente sweater all the time.
So it's basically extending your student life a bit.
Maybe.
Next question. Do I need to choose a specialization right away? Yeah, maybe a good question for Cici.
No, not immediately. So indeed, there are maybe already some compulsory courses in the beginning for specialization, but actually quite a lot of the professors, I think all of them, are very flexible. So if you made a decision and then later decide, okay, no, I do want to do something else, then together with the study advisors, there's always an option to shift. And so, yeah, it's all very flexible.
Okay, clear.
Yeah.
Next question. How can I apply? So I mean, I suppose that means how to apply for the Master Applied Physics. I think that's also a question for you, Cici.
Yeah, so you can do that via the website, of course. So it will be in the chat, I think, how you can apply.
Yeah, we'll send a link in there.
Yeah, and but always in all cases, it's best to also contact the study advisor to see what we can do to lend you here the best way.
Yeah. Okay. Next question. How was your graduation experience? Again, Nick. Oh, no questions for Nienke.
A lot of fun. So your graduation experience is where you can truly shine for yourself. Like you have, of course, your defense, which is a big deal. Like you're going to be sweating. You're not going to get a lot of sleep right before that. But your graduation experience, you write a beautiful thesis that is your own work. It takes you months of work, but you're, of course, going to be very proud of it. Then your defense, it's your moment. Do whatever you like. Stay a bit formal. I did it a bit informal, but everyone likes it in the end. So I really loved it, and I am still excited to stay here at the university.
Okay. Well, that sounds really fun, or at least tough, but you made something fun out of it.
Yes, of course, you have to.
Okay. Thank you all. That was it already. So, after seeing this live stream, you think the Master Applied Physics, I'd like to know more about it. Well, you can of course still ask some questions to our chat team. They're still fully ready and eager to answer the questions you have. Or you can also sign up for an online meetup with one of our students. So you can have a little bit more one-on-one chatting and gain some first-hand experience. Also, it's possible to visit our campus and register for a campus tour to see all the nice buildings, the green we talked about, and also gives you an opportunity to chat with some students. And as Cici already mentioned, you can just contact the study advisors if you have more detailed questions about your special case maybe, or what do you need to know, etc. And that's it for today. Thank you all again for joining. Nice that you've watched, and have fun with the rest of your online open day. And hopefully see you soon here at the University of Twente. Bye.